So we are discussing S series 4, question number 42. It belongs to topic of transducers, and the further classification goes for a strain gauge. So I'll read question for you. A strain gauge bridge shown in the given figure has two fixed resistors R1 and R2 of 120 ohm each and a variable resistance R4 which is 120 ohm at zero strain and 120.63 ohm with a strain of E. So when strain is given, then the value of resistance will change and it becomes 120.63 ohms. The gauge factor is 2.04. Determine the strain where the gauge is attached. So now I'll draw the bridge circuit for you. So it's a simple Wheatstone bridge configuration. So it goes like this. And here is your gauge. It's R1, it's R2, R3 and R4. And here is your power supply. And it's G. Then so if we go to for the solution of this, then we can say that resistance of unstrained gauge, that is when a strain is that is when the force pressure is not applied. So when it is unstrained, then we denote it by R3U. U will denote unstrained, U denotes unstrained. So it is given by R3U. It's a simple Wheatstone bridge formula, or simple the way we solve Wheatstone bridge. Ratio of the resistances, so it comes like this. So by putting their respective values, we have 120 cross 120 divided by 120. So now we have the value as 120 ohms. So this is the value when the gauge is not strained or it is unstrained. So the value of gauge resistance when it is unstrained is 120 ohms. So now if we'll apply strain, then there will be the change in resistance. So we'll go as change in resistance. We'll say it by this is delta R4, a small change. In order to balance the bridge, when strain is applied, is given by, so we have delta R4 is equals to 120.63 minus the actual value, that is 120. So we have 0.63 ohms. So this is the small change in resistance which will be observed when in the R4 in order to balance the bridge. So when you apply the strain. So change in resistance of unstrained gauge. So change in resistance of unstrained gauge so you have delta R3U. Okay, delta R3U. So what is the change? So similar formula, put the value of delta R4 what we have calculated earlier. So it goes as 120 by 120 into change in the value we just calculated. So please substitute it. Then we have it as 0.63 ohms. Okay, so now gauge factor is given and we know the formula for gauge factor. So gauge factor is equals to delta R3U, that is change in resistance to the strain. So we have to find the value of E. So it goes as putting all the respective values divided by 120 upon 2.04. So we have the value of strain as 25.4 into 10 raised to the power minus 4, and as we all know it's a unitless quantity, so it will be our answer. So if you look towards the option, then option number B is correct.